Unit 3 begins. 3.2, remember 3.1 was a part of our Unit 2. We covered 3.1 and 3.4 in Unit 2. Today's date is 10/2/19. And our goal in this lesson on measures of variation is to be able to calculate the measures of variance, standard deviation, and range, which we are already proficient in finding the range. So just two things. There's two most common measures of variation. First of all, the range. And we know to find the range, we just subtract the minimum value from the maximum in any data set. The pros of the range. The range can be helpful because it indicates that there's a difference, in our example from the opener, between the height of the tallest person and the smallest person. So it gives us some sort of understanding for that information. The cons are that it only utilizes two pieces of information. And so it actually doesn't tell us much about the data set as a whole. The second most popular measure of variation is called standard deviation. So it measures variation by indicating how far, on average, the observations are from the mean. A high standard deviation for a data set with a large amount of variation, for a data set with a large amount of variation, the observations will be, on average, far from the mean. A low standard deviation for a data set with a small variation, the observations will, on average, be close to the mean. The pro of using standard deviation is that the standard deviation is preferable to the range as a measure of variation because the standard deviation takes into account all of the observations, whereas the range, like we said, considers only the largest and smallest ones. The con is that the standard deviation is not resistant to outliers, just like we learned with the mean. The mean is not resistant to outliers because we're incorporating in all the numbers to calculate the mean. And the standard deviation, the whole focal point of standard deviation is the mean. We're going to be comparing all of the numbers in the data set to the mean. And here's some steps. I love steps. They help me work through the problems. Number 1, calculate the mean. Show me on your hand on a scale of 1 to 5 how confident you are in calculating mean of a data set. Thanks. You're my most creative class, so thank you. I see a range of 3 to 5. Can someone sum up how to calculate the mean for any data set, Casey?
You add all the numbers together and then divide it by the number of numbers.
That's it. Good. Subtract the mean from each data point is step 2. And those are called, once we do that subtraction, it's called a deviation. So if we add the deviations from the mean, we get 0. If we add them all up, we get 0. Therefore, in our next step, we are going to square the deviations. Then we don't have negative numbers anymore, right? If we square numbers, even if they're negative, they become positive. So step 3, square each difference from step 2. be sure to use parentheses when squaring negative numbers. Don't forget it. Step 4. Sample variance. The symbol for sample variance is s squared. Lowercase s squared. In the definition, it's the calculation of the mean of the squares that we just calculated. Now for population standard deviation, we have a different symbol. It's the lowercase letter s in Greek. It's a lowercase sigma. And that's what we're using if we were doing population standard deviation, in which we would divide the sum of the squared deviations by n. Recall n is just the number of data points. Number of data points. You learned about n in lesson 3.1. So that was like last Thursday. For sample standard deviation, lowercase s, we divide the sum of the squared deviations by n minus 1. Which seems weird. It's kind of a weird concept to wrap your mind around. I'll try and explain why that is. One of the main uses of sample variance is to estimate the population variance. So division by n tends to underestimate the population variance. So if I take a number like 100, this is like number sense. I feel like sometimes it's helpful to see it, an example. If I take the number 100 and I divide it by 10, I get what? 10. If I take the number 100 and I divide it by something smaller than 10, like 5, what do I get? 20, yeah. So when we're talking about variation, like, it's the spread of our data. So when we're just looking at a sample of the population, all we can do is make an estimate. Just like when you did your surveys and you got responses, it didn't necessarily exactly represent what everybody thought about your business idea, but it was, close. You surveyed 30 people. If you surveyed everyone, you would have a more accurate answer. But you can imagine that there would be more variation than what you just sampled. And so when we divide by something slightly smaller, like we did here, it gives us kind of more cushion room. So we have more flexibility within what we're calling our standard deviation, since we're only dealing with a sample, not the entire population. So division by n minus 1 in the sample variance tends to give the accurate value for the population variance. You all are flipping because you didn't see my little incognito step number 5 at the bottom here. Step 5, standard deviation. That's the last thing. That's the last step. Standard deviation gets the symbol lowercase s. And again, this is for sample standard deviation. And all we do to find the sample standard deviation is to take the square root of the variance. The symbol for variance is s squared, right? How do we get to s? Just square root it, right? So even within there, the symbols that they've been given, we can see the relationship there. The standard deviation is the square root of the variance. Now you can flip. Now this is referencing our opener. maybe a more accurate picture of our basketball players here than my little children in the opener. We're going to find the sample standard deviation for team 1. I've already put this chart here for you, but I highly recommend using a chart. It's just a quick little sketch to make a chart like this. We're going to put the height in inches of all of our team members from team 1, 72, 73, 76, 76, and 78. The good news is you've already calculated step 1 in your opener. Remember this symbol, X bar? That was also in 3.1 notes. The way that we say that is X bar. X bar is the sample mean of a data set, which is what it tells us to do in step 1. What was the mean of this data set from your opener? Liberty? Good, 75. So if you flip to the front, that was step 1. Check. Step 2, we had to find the deviation, the difference between each data point, X, and X bar, the mean. So we're just going to do 72 minus 75, which is negative 3. 73 minus 75, which is negative 2. 76 minus 75, which is 1. And again, and 78 minus 75. Step 2, check. Now if we add all these together, we get 0. And therefore we have to do step number 3, which is square the deviations. So we did step 1, mean. Step 2, subtract them to find the deviations. Square them, we did that. Step 4 is to find the sample variance, or S squared, by calculating the mean of the squares. We got to add them all up, that's 24. We have to divide by n minus 1. What's n for this data set? Mac? For this data set? How many data points are there? 5. And we're going to subtract 1 again to read that cushion. So 24 divided by 4. 6 is our S squared, which again is our sample variance. All we have to do to find our standard deviation is take square root of that, right? But we're going to write the whole formula out here real quick. To find standard deviation, I'm going to write that standard deviation. I have to take the square root of S squared. But to calculate S squared, we went through some things. So we're going to put all of that into this formula. We had to add together. This symbol here means take the sum. It's the capital letter sigma. Take the sum of all of these right here, all of the X minus X bars. And then divide that by n minus 1. So in our problem, since we've done all of those steps, all we have to do is to take the square root of 6. And what's the square root of 6? Okay, so 2.44. Thank you. And that's our standard deviation for our basketball players in Team 1. That's it. We just calculated standard deviation. That's the most calculation intensive topic. It's right up there at the top with some of the others. It's no more difficult. However, it's made up of a bunch of steps that are pretty simple, right? Step 1, find the mean. Step 2 is like make this chart where you list all the data points, find the differences, and then square them. And then step 3 is find that S squared, the sample variance, right here. And then step 4 was take the square root. That's it. You guys want to find a quicker way? I do have a tool that you can use called Microsoft Excel. So I'm going to teach you on a small scale to be computer programmers today using Microsoft Excel. So I've left some space here under example 2 to take your own notes. I'll say things you should write down. I highly recommend you write them down. We have a quiz on Friday. You can use your notes. So at this time, get out Microsoft Excel, and we'll walk through example 2 together using my favorite tool.